Question 35. The triangle PTA is shown. The length of PA is 75 meters and the length of PT is 51 meters. The angle of depression from T to A is 36 degrees and the angle PTA is obtuse. So, find the length of TA and give your answer correct to 2 decimal places. Firstly, they've given us 51 and 75 in the diagram, but I want to put the angle of depression in. So it's saying from T to A. So when we're looking for the angle of depression or the angle of elevation, we have to draw a horizontal line at the point that it's saying it's from. So here it's saying it's from T. So we draw a horizontal line at T, and then the angle of depression is the angle going down. So this is 36 degrees. And if it was elevation, it would be like this angle here, but it's not in this situation. Now, if we have these two horizontal lines which are parallel, that means that this angle here is also 36 degrees. So that's within the triangle and that's going to be valuable to us. Now it says find the length of TA. TA is this line here. Okay, what are we going to do? There's not a lot of information. There's a couple of steps we have to take, but it's possible. So firstly, I'm looking, this 36 degrees is opposite the 51, and then we have this 75 degrees, and that's going to be opposite this angle here. I'm thinking let's start here. So for this, I'm going to use the sine rule. So let's do 51 over sine 36 equals 75 over sine angle PTA. So this angle up here, PTA. Okay, so angle PTA is equal to, so if we multiply the sine up here, and then we divide the 51 and multiply the sine 36 up to the 75. So this will equal 75 times sine 36 divided by 51, and we'd need to do inverse sine to get that sine away from the angle PTA. So I've done a lot of steps in this line. You can break it down if you want and just take it step by step, and you should get this at the end. Now if we put this into the calculator, we will get 59 degrees and 49 minutes, and this is to the nearest minute. They've said that angle PTA is an obtuse angle. So if it's an obtuse angle, whatever value we got when we just did the regular sine rule, cos rule, whatever, we just have to do 180 minus that, and that's the actual value for that angle. So since it's obtuse, angle PTA equals 180 minus 59 degrees and 49 minutes, and that equals 120 degrees and 11 minutes to the nearest minute. Okay, so let's do another color now. That's all we got for this this angle up here. So this is 120 degrees 11 minutes. Now, since there are 180 degrees in a triangle, we can find this angle as well, because we know the other two angles, 120 degrees 11 minutes and 36 degrees. So we can do 180 minus 120 degrees 11 minutes minus 36 degrees, and that equals, so TPA, let's actually label this. Let's move this over. So angle TPA equals this, which equals 23 degrees and 49 minutes to the nearest minute. Okay, So this is 23 degrees 49 minutes. Now, finally, we're going to try and find TA. So TA is our unknown side, and I'm thinking we use the cos rule because we have the other two sides and we have the angle in between those other two sides as well. So the angle in the cos rule always has to be in between the two unknown sides. So therefore, c squared, which in this case is TA, so TA squared equals a squared, let's do that as 51, plus b squared, which is 75, minus 2 times 51 times 75 times cos 23 degrees 49 minutes. And so then we find out what all this is equal to. We also square root it so that we can get TA, and that should equal 35.04 meters to 2 decimal places because it asks for correct to 2 decimal places.